Hi everyone. Today I'm going to make a quick little recording on a torque problem. This one's going to be fairly simple. We're going to be basically just applying the definition of torque. Let me zoom in a little bit so we can read the question a little better. So this question says, a worker applies, this is basic, by the way, question 2 from chapter 8. I don't think I assigned this one, but a worker applies a torque to a nut with a wrench of 0.5 meters long. Because of the cramped space, she must exert a force upward at an angle of 60 degrees with respect to a line from the nut to the end of the wrench. If the force she exerts has a magnitude of 80 newtons, what magnitude of torque does she apply to the nut? So first, let's go ahead and draw this problem. Let me go ahead and move it over here so I can draw it freehand. So we're going to try to figure out what this problem is saying. So let's go ahead and draw the nut polygon. Let's make it a little nut right here. There's going to be our nut, our hexagonal nut. And we're going to make it gray. Okay. And then we're going to draw a wrench around it. Like so. Okay. And then we have the line from the end of the nut here to this right here. Let's make that black, make it a little bit bigger. Okay. And so she pushes, the worker is pushing upward. So let's go ahead and draw that force in blue. Well, let's do, I've been using this. Oops, not that one. So we're going to make a blue line here, or a hot pink line. It's going straight up. Make it blue, hot pink. Let's make it a little bit shorter. Okay, and let's go ahead and make a little arrow tip on it. Let's go back to arrow tip on right here. Oops, other way. No arrow on that side. I want arrow on this side. I think the first one is the right one. I just need to make it smaller. So let's make it like 70 instead. Oh, I see. There we go. That's good. Okay, so that's me our force here. Let's make this one also have an arrow tip here. Tip to the other side. Also going to shrink this down. There we go. Okay, so this is going to be our R here. And this is going to be our F. Okay. So we're going to also say that at angle 60 degrees, let's make that theta here. So we got angle theta here. Let's go ahead and put that in as grab that theta. Well, there it is. Or grab that theta. Put it here. I guess I didn't copy it. One sec. Put it here. There we go. And so we can start adding the details here. So we have that F equals 80 newtons. R was half a meter. And theta was equal to 60 degrees. Okay. And so now all we got to do in this problem is we need to find the torque does she apply. All we got to do is the definition of torque. And the definition of torque is tau. Let me make it a little bit larger. So tau equals F cross R. If you do it in vector form, or if we just want the magnitude, we can just do F, magnitude of F, magnitude of R, and then sine of theta. What size we got all these? What size is this? Okay. All right. And this problem, all we got to do is just plug the numbers in. So F was 80 newtons. R was half a meter. Put the units in. And theta was 60 degrees. So that means that this is going to be 40, and then sine of 60 is going to be root 2 over 2. Let's go ahead and do a quick calculation for that. We do that off the side here. Take just a second. Okay, so we got 40 sine of 60. So take just a second while it calculates. It's going to be equal to 34.6. Now, the units here are going to be Newton meters. So I always write it like this because it's not a joule here. And that is the answer to this question. Okay, and that's just a short little video on applying torque.